One byproduct of this whole project is just how incredibly beautiful the brain is, and how this project kind of creates this high-resolution map. Just looking at these neurons shows you their detail and scale in a way that makes you appreciate the brain with a sense of awe, in the way that when you look up, say at a picture of a galaxy far, far away, and you think about, all of those stars and all of the millions of planets.
For the first time in the mouse, we imaged a millimeter cube of the cortex of the mouse. It's the size of the grain of sand, but actually contains almost 100,000 neurons, 4 kilometers of axon linking these neurons, and in this case, 500 million synapses or connections between these neurons.
This project, started with the team at Baylor taking a mouse and doing a heroic physiology experiment where they tried to record from every neuron in this chunk of the brain, which meant working over several days non-stop throughout the day to try to get all this data recorded from a single brain. And then that mouse literally had to be shipped here to the Institute, imaging it across a fleet of microscopes, producing these 100 million images. And then we worked with our colleagues at Princeton to take those images and fine align them into this three-dimensional volume, and then run some of the largest scale machine learning that's ever been done to try to trace all of the axons.
We're starting to build brain foundation models that span many levels of analysis, starting from the behavioral level to the representational level, neural activity, and then down to the connectomics and the cell type level.
Let's imagine that you record all of the conversations in a party, and you know what each person is saying, but you don't know with whom they are talking to. And then separately, you get that information to whom each one is talking to. So if you just have the two separate, you might not be able to kind of make sense of it, because you don't know who's talking to, who's replying to. You just have a map of the conversation, and the other one, you don't know what people are saying. But by putting these two together, you get both to know what each person is saying and to whom is talking to. And that's really special about this.
How can we not want to know what we think with? What are the parts in this part of the brain? How do they interconnect to do the computations? But also, it's the part of the brain that goes awry in all sorts of diseases, in degenerative diseases, Alzheimer's. There are cortical lesions. They're lesions of the circuit that we're studying. And I think if you don't know what are the building blocks and how they connect, it's hard to think about when it goes wrong.
That will be a platform that we can create that will, I think, in the future revolutionize our ability to treat neuropsychiatric diseases or study the influence of drugs and other changes on the brain.
So what we can see in the data is that each kind of inhibitory cell has a super specific kind of connectivity. It really reaches out, and it doesn't connect to all the cells in it. It really picks out specific cell types on the other side and inhibits a subset of them and doesn't inhibit other ones.
If I'm, let's say, an axon and I'm moving into the room you're there, I will choose to connect with people or neurons in this case that are more related to, let's say, what features in the world I like. Let's say if I like the color red versus green versus where in the visual field that feature is.
I think it's really unarguable that the part of the brain that has had the most expansion in the human, and the part of the brain that we think with, we plan with, we have ideas in, is the cerebral cortex. And that's the part of the brain that we reconstructed.
The data is so rich that you can come again and again to examine new hypotheses, look at connections between new cells or between the neurons.
A theme of lots of things that we do here at the Allen Institute is that we're trying to create resources and atlases that everyone can use for a long time. So the purpose of doing this is to try to lay down a map that will be useful, not just for us and what we're doing in this package, but really useful for a huge range of people and hopefully generations to come.